Hello, everyone. We already know that to achieve Profibus field bus communication with industrial robots, certain software and hardware conditions must be met. This knowledge has been explained in detail in previous lessons. Please follow the steps to set it up during practical exercises. This lesson mainly covers the following content. Our communication case study for this lesson is writing programs for PLC and industrial robot. The program for PLC and industrial robot should achieve the following functions. If the PLC issues command A, the robot moves to point P to pick up the goods and transports them to location A. After a 2-second pause, it returns to complete command B and then goes back to the home point. If the PLC issues command C, the robot moves to point P to pick up the goods and transports them to location C. After a 2-second pause, it returns to complete command D and then goes back to the home point. Analyzing the task function, we can see that after picking up the goods, the robot's actions will branch into two paths, moving to location A and location C. Therefore, at least two digital input signals need to be configured to receive commands from the PLC. Similarly, after completing the transportation, two digital output signals need to be configured to convey information to the PLC. After clarifying the number of signals needed, we proceed to configure the I/O for the industrial robot. DI-121 and DI-122 are used to receive commands issued by the PLC, corresponding to the PLC's Q121.0 and Q121.1 ports. DO-121 and DO-122 are used to return completion signals to the PLC, corresponding to the PLC's I-121.0 and I-121.1 ports. We need to set up the I/O signal assignment on the robot's teach pendant using Profibus communication mode, with rack number and slot set to 67 and 1 respectively. Initially, we can set it to 1. After setting this up, restart the robot to make the settings effective. Once the I/O configuration is complete, let's write the robot program. In practice, after the PLC issues a command, we run the robot's main program and use conditional comparison instructions, if, to call different subroutines. The two subroutines execute command A and command C issued by the PLC, picking up cubes and transporting them to different locations, then provide feedback to the PLC and return to the home point upon completion. Next, we will write the PLC program. In the TIE Portal Software's left project tree, click on PLC_1, Program Blocks, Main, OB1, in sequence to enter the program editing page. On the program editing page, insert PLC instructions and write a ladder diagram program. The reference program is as follows. Program segment 1 is for initialization. Program segment 2 is used to issue command A to the robot. Program segment 3 is used to issue command C to the robot. Program segment 4 shows the completion of executing command A. Program segment 5 shows the completion of executing command C. After completing the PLC program, it needs to be compiled and downloaded into the PLC for subsequent debugging. Before running the PLC program, ensure its correctness and reliability to avoid potential safety risks. This reflects our emphasis on safety and responsibility. In future studies and work, you should also take your tasks seriously, develop rigorous thinking and working methods, pay attention to details, and ensure the safe operation of systems. After downloading the program, we put the PLC in monitor mode for debugging. Right-click on M10.0 in Program Segment 2 and force it to 1. The PLC will send command A to the robot. At this time, open the robot teach pendant I/O monitoring and DI-121 becomes equals on. This indicates that data transfer between the PLC and the robot has been achieved. Similarly, you can force the value of M10.1 to 1 to test the data transfer between the PLC's output signal Q121.1 and the robot's digital input signal DI-122. 1. Running the robot's main program, we can see the robot moving from the home point to point P, picking up the block and transporting it to point A, releasing the gripper to drop the block, waiting for 2 seconds, and then returning to the home point. 2. Meanwhile, the robot sends feedback signal B to the PLC program, setting I121.0 to 1, and all segments in program segment 4 are illuminated. 3. Next, execute Command C. After initializing the PLC program, force M10.1 to 1. 4. Running the robot's main program, we can see the robot moving from the home point to point P, picking up the block and transporting it to point B, releasing the gripper to drop the block, waiting for 2 seconds, and then returning to the home point. Meanwhile, the robot sends feedback signal D to the PLC program, setting I121.1 to 1, and all segments in program segment 5 are illuminated. With this, our project function demonstration is successful. We have achieved data interaction between the PLC and the industrial robot under Profibus communication mode, making the robot execute different subroutines according to our requirements. Thank you all for your learning and watching. See you in the next lesson.